Hello everyone and welcome to this cloud coaching session. Today we will be talking about Oracle Analytics Machine Learning and we will understand one machine learning algorithm which is Logistic Regression. My name is Rakesh Chhoria. I am part of the EMEA data platform specialist team at Oracle here and I specialize working on Oracle Analytics products, both Oracle Analytics Cloud as well as Oracle Analytics Server. A standard safe harbor statement. This cloud coaching video is being created for educational purposes where the intention is to help understand the machine learning algorithm in a better way, understand the different parameters of it. So as I mentioned, the agenda for today's video would be, we will talk about the various machine learning features that are available in Oracle Analytics, and then we will understand what logistic regression algorithm is all about, what is it based on, what parameters are available, and then also understand the machine learning model, quality of the machine learning model that gets built, followed by a demo. So let's start with Oracle Analytics Cloud Machine Learning. So there are many different options of machine learning that are available in Oracle Analytics Cloud. The first one is where Oracle Analytics Cloud provides inbuilt features to train, test, and apply machine learning models within OAC. So these are those inbuilt features that are available in Oracle Analytics Cloud. The second option would be Oracle Machine Learning Models, where you have, say, a data residing in Oracle database. So you use the machine learning capabilities of database to build machine learning models within the database and then use them in OAC. And the third model is OCI machine learning models, where you have pre-built models, especially on the AI services side, okay, which you can use the pre-built models and then apply it in Oracle Analytics Cloud. In today's session, we will be talking about Oracle Analytics Cloud predictive models. So the predictive machine learning capabilities within Oracle Analytics Cloud primarily caters to citizen data scientists. So by citizen data scientists, what we mean is that these are the business analysts, okay, who understand the data within an enterprise very well, but they might not have deep technical expertise, say, to build machine learning models using programming languages. So the idea is to provide the business analysts an easy to use interface using which they can build machine learning models, understand the data better, and maybe ask better questions. Now, Oracle Analytics predictive machine learning supports both supervised and unsupervised learning. We use the feature of data flow within Oracle Analytics Cloud to train the machine learning models, and then we can also apply the machine learning models using data flow. Now, machine learning is supported for the following categories: numeric prediction, classification, it can be either a binary or multi-classification, and clustering. So now let's look at a little bit into what is supervised learning and what is unsupervised learning. So supervised learning, it describes a class of problem that involves using a machine learning model to learn a mapping or relationship between input examples and the target variable. So the input would be what we call as independent variables within a data set, and these independent variables would have a relationship with our target variable. Common algorithms used are naive Bayes, CART, neural network, linear regression, logistic regression, and support vector machines. Some of the examples of supervised learning machine learning would be sales forecasting, classifying transactions as fraudulent or not, predicting real estate prices. Now coming to unsupervised learning. So this describes a class of problems that involves using a machine learning model to describe or extract relationships in data. So we don't have any historical data or relationships defined. We are trying to identify or extract relationships in data. So that's why it is called as unsupervised learning. Common algorithms are k-means, hierarchical clustering. Examples would be customer segmentation, inventory grouping, or market basket analysis, designing recommendation systems. Now, in this slide, what you see are the various machine learning algorithms that are available within Oracle Analytics out of the box. So we have algorithms for numerical prediction, classification, both binary and multi-classification, as well as clustering. In the previous video, I had talked about naive Bayes machine learning algorithm. And in this video, we will be talking about logistic regression. As you can see, logistic regression is a machine learning model used primarily for binary classification. So now let's deep dive and understand what logistic regression is all about. So logistic regression is a powerful classification technique. Now, as the name suggests, regression usually deals with numbers or numeric prediction, right? But logistic regression is a special regression algorithm which is used for classification technique. So how does it work? It works in two steps. So the first step would be we use the independent variables to estimate the specific value or relationship of the dependent variable. And then once we have the predictions, we actually transform them using a function called as sigmoid function, also known as logistic function. So the output of applying this logistic function to a predicted value would be something like this, where you will see an S-shaped curve and the values would stretch between 0 and 1, but never being 0 or 1. So they'll be closer to 0 or closer to 1, okay, but they'll never be 0 and 1. So if we have to represent the logistic regression using a formula, so the first step would be what we call as linear method, where we'll try to predict the values in a linear fashion. So the formula for that would be, say, y equal to a plus b1 x1 plus b2 x2 so on, where a would be the bias or intercept and b1 to bn would be the coefficients and x1 x2 are the various independent variables. Now once we have this linear method identified, the values identified, then we apply the logistic function, which has a formula something like f of y is equal to 1 divided by 1 plus e to the power minus y. So this logistic function would create an output on the predicted values in an S-shaped curve, as you can see in the diagram. Now, what are the key points of logistic regression? Now, logistic regression can be used for binary classification. So now, as I mentioned, right, the output would be values between 0 and 1 in an S-shaped curve. So you can identify 1 could be the primary class in the data set and 0 could be the non-primary class in the data set. The logistic regression algorithm is fast, highly scalable model. Okay, it scales linearly with the number of predictors and rows, and it does not require large amounts of data. One thing to note is when doing the data preparation for better predictions using logistic regression, it's always recommended that you remove highly correlated input columns or outliers. So by highly correlated input columns, it would be something like, say, you have a time column, you have a date, then you have a month, quarter, and year. So they are correlated, right? So you can remove those. Sometimes you have derived attributes, like say you have an income column where you have values, say, ranging from 50,000 to say 200,000, and then you have already created a bin column on top of it where you have classified it into, say, 50 to 75,000, 75 to 100,000, 100 to 150,000, so on and so forth. So this salary binning column is a dependent column on it. So it's better to remove that column when trying to build the machine learning model. Okay. So with this basic understanding of logistic regression, let's understand what are the various parameters that are available in Oracle Analytics Cloud for this particular logistic regression algorithm. So the parameters, here is a list of parameters, around 10 parameters are available. So let's look at each of these parameters in a little detail. So the first parameter is what we call as target. So this is essentially the column within the data set that we want to predict by building the machine learning model on. Okay. Now, positive classing target. As I mentioned, logistic regression is a binary classification. So the column on which we are predicting, the target column, would have two values, 1, 0, yes, no, y, and so on and so forth. Now, for this parameter, the positive class default value is yes. But if you have a data set where you have 1 and 0, you can identify based on the use case whether 1 is a positive class or 0 is a positive class. Next is predict value threshold percentage. Now this is a new parameter when compared to naive Bayes. Okay, and this parameter is very important because it identifies the threshold, okay, beyond which the machine learning model would actually identify one of the two output classes. So to give you an example, like let's say when we keep the predictive value threshold percentage as 50. So when the machine learning model is predicting the output and the prediction probability is more than 50% or more, then it will treat it as the primary class. Okay. If it is less than 50%, it would treat it as the non-primary class within the data set. So this is very helpful because all the time 50% might not be the requisite threshold. Sometimes we might have to go with higher values and sometimes lower values based on the data set and the population of that data set in terms of the output values of the target column. Okay. The next parameter is maximum null value percent. This identifies how many nulls within a particular column are allowed and the threshold beyond which that column would not be considered for machine learning model building. The default value is around 80%. The next important parameters are around column imputations. So by column imputation, what I mean is if you have nulls in the data set, how would you handle these null values? So there could be two types of data set. Either you have categorical or text based columns, or you have numerical columns. Now for categorical column imputation parameter, this parameter will allow you to replace the nulls with one of the two options. Either you use the least frequent value or the most frequent value in the column. For numerical column imputation, you get 4 different options. You have mean, maximum, min, and median. So any one of these can be used to replace the null or NA values in that particular column. Again, now when machine learning model is built, it's always what it would do is, even if you have say text data in columns, right? It will always try to convert it into numerical values and then build a machine learning model using those numerical values. So this is what we call as categorical encoding method. So this parameter determines how we will do the encoding of the categorical or the text columns within the data set, and then we will do the machine learning model building. Now for encoding method, we have 2 values available, indexer and one hot. So by indexer, when we select the option as encoding method as indexer, what it would do is, let's take an example. Say we have a text column called as region and we have 3 values, Europe, Middle East and Africa. So if I use indexer as the encoding method, what it would do is, as there are 3 distinct values in this data set, it would replace these with say values 1, 2 and 3. So 1 would be Europe, 2 would be Middle East and 3 would be Africa. So that's how it would replace these text values with numbers as an index and then build the machine learning model. Now if we use one hot as the encoding method, then what would happen is that it would actually create number of columns based on the distinct values. So if I stick to this example of region again, so we have 3 values, Europe, Middle East and Africa. So in the data set, what it would do is it would actually add 3 new columns and it would name them something like is Europe, is Middle East, is Africa, and then the value will be populated as yes or no. So if a particular row in a data set has a region as Europe, then is Europe would be set as Y and is Africa, is Middle East would be set as no. Okay, so we can select any of these encoding methods based on the data set that we have. The next parameter is train partition percent, which essentially means that the training data set that we are using to build the machine learning model, how much percent of that data set should I use to train the machine learning model and use the remaining data to actually test the model that is built. And once the testing happens, you actually have a quality of the model, which we will inspect also to identify how good is the model, machine learning model that got built. Okay. And again, here the default value is 80%. Next important parameters are number of k-folds. Now this is again a very important parameter. It usually determines the number of groups in which you will divide the training data set and then use these groups of data for cross-validation. So this cross-validation, essentially what it would do is, let's take an example. Say I have a training data set with 1000 rows and I have said that the number of k folds would be 5. So that means it would divide that 1000 row data set into 5 groups, each with say 200 rows of data. Now, what it would do is, in an iterative way, it would select one group as test data, and the other 4 groups of data would be used to train and build the machine learning model, and that model would be tested on the 5th group. So this way, it will do the iteration for each of these and then give you the best machine learning model that it generated. So this is a very important parameter where we would like to say avoid the biases in machine learning model based on the training and how we build the machine learning model, right? So this is a very important parameter. Now, one thing we need to keep in mind is keeping a value too low or too high makes it ineffective. The suggested range or kind of a recommended one is any value between 5 and 10. So the default value is set as 5 for this parameter. And the final parameter is what we call as standardization. So this parameter actually determines whether the input data needs to be standardized or not. So by standardization, what I mean is that, so we might have a data set where we have say different attributes, and these attributes might have different ranges or significance. Let's say I have a data of a user where I have say height of the user, weight of the user, also annual income. So the height might be captured in centimeters, the weight might be captured in kilograms. So the range could be say between 50 and 120 for weight. For height, it could be anywhere between say 150 centimeters to 180, 190 centimeters. And then income could be somewhere between 50,000 and maybe 200,000, 300,000, right? So the range of values is very different for each of these columns. Now, imagine a situation where if you don't standardize it, then the column with the higher range or higher values gets precedence. So to ensure that each of the columns get a fair chance when trying to build a machine learning model, we can set the standardization parameter as true. By default, it is set as false. Okay. So these are the various parameters that are available with the logistic regression algorithm for building the machine learning model as well as tuning it. Again, as we have talked about machine learning model quality, right? Here you see an example of a machine learning model that was built. So this is how the quality would look like. We have on the right hand side, what you see is the confusion matrix, okay, where we are trying to plot the actual values and predicted values. And we are trying to get the various quality parameters like accuracy. Again, here I would like to mention one thing, that the model accuracy in earlier times, model accuracy was kind of the main quality parameter that was used to identify how good a model is. Okay, but over a period of time, it has been identified that only accuracy might not help, because if we have say data sets where we have skewed data, then the model accuracy does not help in having a better quality model. So additional parameters like precision, recall, false positive rate, F1 value are also being considered when determining the quality of the machine learning model. So for each of these parameters, we have the formulas on the slide. So for this particular model, if you see, these are how the numbers stack up. Okay. So with this short introduction on logistic regression, what it is and what is it based on, then what are the different parameters that are available in Oracle Analytics Cloud, and also a small overview on the ML model quality and how we calculate the machine learning model quality. With this, I'll move into the demo part. So for the demo, what we will do is we are using a sample data set, user demographics data. We will use it to build a machine learning model to predict if a customer is likely to buy an affinity card or loyalty card or not. Then we verify the quality of the model. We understand the parameters, like as we have done, right? We have already given an overview of the different parameters. So we will change the values of these parameters, tune the machine learning model in iteration, and then check the output. So with this, we will jump into the demo. Let's start the process of building a machine learning model using the data flow. So I'll open here a data flow where you see that the first part of the data flow contains the data. So this is the demographics data that we have, and we are using a subset of that data to train and build a machine learning model. So we have a data set where we have the customer ID, their education qualification, occupation, household size, years in residence, so on and so forth, affinity card, and all the other details that we have available. Now, as to build a machine learning model, as we had mentioned, right, Oracle Analytics Cloud supports these are the different categories of machine learning model building, be it numeric prediction, classification, multi or binary, or even clustering. So in our case, it is binary classification. So we have selected the task as binary classification. Now, out of the box, as you must have seen in the presentation slide as well. So we have six different algorithms that are supported for binary classification. We will select logistic regression. Okay. Now the first parameter that we need to select is the parameter on which we want to build the machine learning model. So in our case, it is the affinity card. So we select affinity card, and this affinity card has two values, y and n. So I'm just mentioning what is the positive class in target. So for first iteration of model building, we will just configure these three things. Where is the model training script, the target, and the positive class in the target. Rest of the parameters we will leave as default. So things like predict value, threshold, percentage, all of these we will leave as default values. Give a name to this particular machine learning model, save and run the data flow. Now once the data flow is run, the machine learning model gets built, and now we will check the quality of the model. So to check the quality of the model, we will navigate to the tab Machine Learning. So here you can see that we have the machine learning model that got built. So if I just inspect, so these are the various tabs, and here is the quality tab. So clearly what we see is in the first iteration of this logistic regression based machine learning model that we built, the model accuracy is 77%, which looks good. The precision is 62%, which again looks fine. The recall is a very low number, it's 11%, which is not that good. False positive rate is 2%, which is very good. So based on these parameters, the overall F1 value is 0.18, which is very low. Now let's understand these quality parameters a little more. So when we say recall is less, 11%, that means the machine learning model, when it is predicting, it has predicted a number of false negatives. So which can be clearly seen in this particular confusion matrix, where the actual value was y and the model has predicted y in 16 instances, whereas for 132 rows it has predicted as n. So we have a very high false negative scenario here. As a result of this, the recall is very low. Now typically when we do this binary classification machine learning model building, it is very important to understand the use case, and based on that, whether a false negative, is it good, or a false positive is good, or how much of it we need to balance, so that there is a balance between the various parameters. So usually for logistic regression, while getting 100% of any one of these parameters, be it precision or recall, is very difficult. So we have to find a balance between these two parameters primarily, and then based on the use case, we decide whether a model is okay or not. So now that we see that we have very high false negative cases, right, in this case, now let's look at the data set maybe to understand why this is happening, and then we will see how to tune the parameters further. So now if I move to the data set here, so as you can see, I've just built a simple workbook in OSE to understand the data. So it is the same data set that we have, the training data set. We see that in the data set, almost 76% of the rows have affinity card as N, whereas 24% of the rows have affinity card as Y. Now, as I had mentioned, right, we have a parameter called predict threshold percentage. Okay. Now, in this data set, it appears like the machine learning algorithm for logistic regression has considered affinity card equal to n as the primary class. Please bear in mind, it's not the positive class, but primary class. So why this is important, I'll tell you. So if the logistic regression has taken n value as the primary class, then what is happening is, based on the data flow that we have created here, if you see the predict value threshold percentage, we have set it as 50. So what is happening is, any prediction probability with 50% or more, it is treating it as the primary class, which is n. Now this could be one of the reasons why we have a large number of false negatives. Okay. Now to address this issue, or to check and verify this particular behavior, let's build one more iteration of the machine learning model where we will change this particular parameter to 70%. So essentially what we are doing is, the predict value threshold percentage, we are changing it from 50 to 70. So what does this mean? That now if the prediction probability when applying the machine learning model on the data is 70% or more, then only please consider it as the primary class, which is n in our case. Okay. Otherwise, if the prediction probability is less than 70%, then consider it as a non-primary class, which in our case would be the y value. So with this one change in the parameter, rest of the other parameters are constant. Okay. We will just give a new name to the machine learning model, save and run the data flow. Now once this data flow is run, let's inspect the machine learning model that got built with this change in parameter. So now what we see is, yes, the model accuracy has come down a little from 77% to 69%. The precision again has come down from 60+% to 41%, but the recall has improved. It was 11% earlier, but now it is 68%, and now the false positive rate has also gone up from 2% to 30%. So now let's understand what is happening. So essentially, when I increased the threshold percentage from 50 to 70, now what is happening is, for all the rows where the prediction probability is less than 70%, it is predicting it as y, and for 70% and more, it is predicting it as n. That's why now we see that when we compare the actual values and predicted values, we see a higher number of y's, from 16 in the earlier case to 100 now, and the n's have reduced from 130 plus to 48. Okay. So clearly we see that n is the primary class here. Now many a times, based on the data set and the cardinality, say we have a data set where it is closer to 50%, both the values, say one is 55, another is 45. It could also happen that we have to try both the cases. So increasing the predict value threshold to see if the parameter that we are trying to tune is improving or not, or we reduce the predict value threshold percent as well from 50 to check. So that way we can actually determine which value in the target column the logistic regression model is treating it as primary class. Okay. So that way, now that with this we clearly see that n is the primary class here. So with this, now let's do one more level of tuning. Okay. So in the third iteration, what we will do is, we will actually increase the threshold percentage again from 70 to 85. Okay. We will leave all of the other parameters as default. Okay. And then we will give a new name to this particular machine learning model. Okay. Save and run the data flow. Now once this data flow is run, let's inspect the new machine learning model that got built with this change in parameter again. Okay. Now here again we see that now the recall has improved from again 68% to 91%. But then we see again model accuracy has come down. Okay. Precision has come down. False positive rate has gone up. And overall F1 value has also reduced from 0.51 to 0.5. Okay. So while we are addressing during this tuning, we are addressing the issue of reducing the false negatives. We are also seeing a situation where now the false positive rates are going up. So in these scenarios, this is where, when I say, right, we have to try to get a balance between the precision and recall. So in our case, false positive rate or false negative rates, right? So there would be an acceptable balance. It would never be like 100% on both the situations, but we have to come to a a value which is acceptable on both parameters, false positive as well as false negative. Okay. Now moving ahead, let's look at one more parameter for tuning. Okay. So now if I look at one more iteration, so I leave the predict value threshold at 85%. Okay. Now one of the other important parameters was number of k folds, right? As I had mentioned. So the default value was 5. Now we are changing it to 7. Now again, just to reiterate what is the importance of these k folds. This is a very powerful cross validation technique where when you build a machine learning model using a training data set, it will actually divide the training data set into number of groups or folds based on the number that you give here. Then it will keep one group for testing purpose and use all the other groups to build the machine learning model. Now this would be done in an iterative way where each group based on the number of folds, right? So if we take 7 in our case, so there would be 7 iterations of machine learning model building that would happen, and it would be tested on each group separately for each iteration, and then the best machine learning model would be created based on the different parameters that are there. So that is the significance of this parameter k folds. Now let's look at whether changing this particular parameter k folds equal to 7, and for demo purpose I have also changed the parameter on standardization from false to true. Okay, now let's, based on these two changes, let's look at and see whether there is any change or improvement in the machine learning model that we are building or not. So I'll give a new name to this, to the machine learning model, save and run the data flow. Once the data flow is run, the machine learning model would get built. Now let's look at the quality of the machine learning model that got built. So here if you see, again, we are getting more or less similar parameters. So based on, say, changing the standardization to true and k folds from 5 to 7, we don't see much of a difference. The F1 value has gone down a little from 0.5 to 0.49. Model accuracy is more or less same, 56%. Precision is 34. Recall is 91%, and the false positive rate has gone up by another 3%, right, to 55%. So now maybe we need to bring down the threshold a little less from 85% and see whether we get a decent value for recall as well as precision and false positive rate. So this could be that iterative process which you try and do to figure out and then identify which particular version of the model with the set of parameters tuned is acceptable for our business use case. Okay. So now that we have 4 iterations done and we have built the various machine learning models, right? Now we'll show, let's apply this particular machine learning model to the test data set and try to see the output of it. Okay. So for this, again, we are using a data flow. So where this is my test data here, similar data sets. Okay. Now, when I select the model, I'm selecting V3 for now. Okay. The third version of the machine learning model that got built. So what it is essentially doing is it will add 2 new columns as output. One is the predicted value and the other is predicted confidence. So the predicted value would give whether it has predicted Y or N as the target, and the confidence is the confidence with which the model is predicting this particular value. Okay. Again, the input columns you can see they are mapped. The data sets are similar. Okay. So we have the same column names here. And if there are scenarios where you are using a test data where the column names are not same, you can actually define the mapping here as well. Once we have these mappings defined here, okay, now the output we will save it as a new data set. Okay, we will save and run the data flow. Now once this data flow runs, the new data set would get created with the predicted values as well. Now for this demo purpose, I have actually built a small DV workbook using the predicted output data. Okay, so if we see here, so this is the predicted data. So the test data had around 1,360 customers, out of which around 83 customers, the model has predicted that they are likely to buy the loyalty card or affinity card. Now, if you do some demographic analysis what we see is, if we look at the predicted values where say the model has identified that these customers are likely to buy the loyalty card or affinity card, if we split those predictions by say household size, we see that we have values ranging from 1, 2, 3, 4 to 5, 6 to 8 and 9 plus, and we see that household size with 3 members is where the model has predicted that the higher probability of customers buying the affinity card or loyalty card. Similarly, when we try to split the predicted values by occupation, we see that for occupation professor, we see that the number of customers buying are likely to buy the affinity card are higher. Now, if I look at by education qualification, again we see that these are the particular qualifications where the customers are more likely to actually apply for affinity card or buy the affinity card or loyalty card. So this way we can do analysis. Now, just for this demo purpose, maybe I'll change the machine learning model applied to a different model, and then we will see. So in this case, let me do one thing. Instead of the version 3, maybe I'll take version 2. Okay, I'll apply. Now again, I'll give this, I'll leave the output names as predicted value and confidence. Okay. Now again, the mapping is done. It is fine. Okay. So now I'll keep the data set as same. Okay, name same. So I'll just now save the data flow. Okay. And now I will run the data flow. Okay. Now that the data flow is completed successfully, let's look at the output of the predicted data set. So I think the model has predicted similar output, because as we have seen, right, the quality parameters were not that different from the various models that got built. So this is how you can actually build machine learning model for binary classification using logistic regression, tune the various parameters, okay, build a machine learning model, and then use it for testing it and applying it on the data sets. Now that we have come to the end of the demo, let's summarize what we have learned in this particular cloud coaching session. So to start with, we understood the various machine learning features and options that are available in Oracle Analytics platform. We have tried to explain what logistic regression algorithm is all about, what is it based on, and how, even though the name suggests it's regression, how it is used actually for a classification problem by using first predicting the outputs in numbers, and then applying a sigmoid or a logistic function to convert those values in the range between 0 to 1. And that's how we have used logistic regression for a binary classification problem. Then within Oracle Analytics platform, what are the different parameters that are available to build and tune the machine learning model built using logistic regression? We understood the machine learning model quality that was built, and then by understanding the various quality parameters, we also tuned the parameters to see and build a better or a more tuned machine learning model. Okay, and all of this we demonstrated with an example where we used predict value threshold percentage as a parameter, where we tuned it initially, say with the default values, then we increased the values to reduce the false negative, and we also saw that decreasing false negatives resulted in increasing false positives. So this is where actually in binary classification, especially when using logistic regression, you need to get a balance between the precision percentage and the recall percentage. It will rarely be a scenario where you have both at 100%. So if one is very high, the other would be low. So we have to tune the model with the parameters available in such a way that we have a balance between these two parameters, and then based on the use case that we have for binary classification, we take an acceptable percentage and then use it to actually predict the classification on the test data or on the real data sets that we will use the machine learning model on. So with this, I come to the end of the cloud coaching session. Thank you all for attending this.